So we've talked about inverses before. Inverses are around because we need to be able to undo things, to solve for variables, to solve equations, to make things work in the world. Like square roots are the inverse of squaring. They undo each other. Well, all of a sudden we have exponential functions. So we have things up in the exponent that sometimes we need to know what they are. Because we have exponents and we need to solve for them, somebody's like, well, man, we got to figure out how we're going to undo an exponent. The inverse operation of exponential functions are logarithmic functions. Logarithmic functions undo exponential functions. Okay? The whole basics. This is how it works. We need them to undo each other. Okay? So today what we're going to look at is we're going to learn how to write and evaluate a logarithmic expression, and we're going to learn what their graphs look like. So, so the key concept is a logarithm with base b of a positive number, x. Now they're telling us something about our domain right here. What does x have to be?
Greater than 0.
Greater than 0. They're telling me with this statement right here that my domain is going to look like this. Okay? We're only allowed with logarithmic functions anything greater than 0 for x's. Satisfy the following. Okay. We're going to practice this.
Is it going to kind of look like a square root?
Yeah, it does, but it doesn't hit 0. You get really close to it. It has a vertical asymptote at 0. So here's what. So we have b is greater than 0. B is not allowed to be 1. Here's what we have. We abbreviate logarithm as log, and we say log base b of x equals y. Okay. Now what that looks like. And the nice thing about logarithms is we can change it to exponential function. Have you guys ever seen that? Have you ever seen IFF before? I did not misspell if. Don't worry. If and only if. Yes.
Is that an x or is that a like a
Instead of x. If and only if. So this means it works both ways. So this is true. If and only if we can change it. So what's the base of the log? B. So that means that we can change it exponential with the base b. So you go b to the y equals x. So we can travel both directions here. If I gave you something that looks like this, you can rewrite it like this. If I gave you something that looks like this, we can rewrite it to make it look like this. So they move. All right, let's do something. We're just going to practice switching the forms, okay? That's all we're going to do right now is practice switching. Do you agree that 100 equals 10 squared?
Yeah.
Okay. We're just practicing writing it in a different form. We're not trying to prove or solve anything. We're just practicing. So let's rewrite this in logarithmic. Okay. So we're going to write this log. What's the base? 10. So log base 10. It's always on the other side of the equal sign. So look right here. What's by himself over here? What goes right next to the log? The x. So log base 10 of 100 is equal to 2 to the exponent. do another one. Do you agree that 81 is the same thing as 3 to the 4th?
Yeah.
Agree with that? Okay. So let's rewrite this in logarithmic form.
Miss White, would they ever give you a problem that's not equal to the other?
Sometimes they'll put variables in there and we have to figure it out, yeah.
Okay.
So what's the base?
3.
3. And you always go on the other side, the equal sign is?
81.
And that equals your exponent, which is?
4.
4. Want to do another one? Good.
What's the point of
We're just practicing right now because we're going to use this to solve. But if we can't switch without a variable in there,
practicing the switching.
we're just practicing switching.
Okay, makes
Okay, I'm not solving anything right now. We're just switching. Thank you. Let's try another one. Okay, I want you to do this one, and I'm not going to do it right now. I want you to do it by yourself. Follow the example. Josh and Cole, please do this right now.
Sorry.
Thank you. What did you guys get?
Log 6.
Log, okay, here's how we say this. Log base 6
Log base 6
of
36
is
2.
equals to 2.
perfect. Alright?
So the 36, is that raised or is that just regular?
That's regular. So, and if you have your book open, they haven't do a much better job of the raised, not raised kind of a thing. Remember, log little b of x. It's not raised to the x. Log base b of x. The book, if you look at there, much more beautiful job of that. Okay. Now here's why we need to do this stuff. Okay. What is the value of this? Log base 8 of 32. The question is, what is it equal? So I'm going to put it equal to y right now. Okay, I don't know what it is. We're not very comfortable with logs. So what are we going to change this into?
Regular?
Standard.
Standard form.
The other one, there's a lot of second
Exponential.
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 So,
That was really hard, but we did it.
Exponential.
So, how do I change it to exponential? What's my base?
32.
What's my base?
8.
8 to the y equals
32.
32. Now, hereby is this helpful. Can I rewrite 8 as something to a power?
Yes.
2.
2 to the 3rd.
8 is the same thing as 2 to the 3rd. So this is the same thing as 2 to the 3y, right?
No.
Are you okay right there? Can I rewrite 32 as 2 to a power?
Yeah.
32 is 2 to the, not the 4th. Fifth. Well, what if the bases are the same? What has to be true about the exponents?
That's really the same.
It has to be the same. So the nice thing is if you can get bases to both be the same, the exponents have to be equal. So because I was able to write 8 and 32 with base 2, I can now just say, okay, well I know that this has to equal to 5. So what is the log base 8 of 32 equal? Y equals
5/3.
5/3.
Do we always have to do it to that step?
Yes.
Okay.
Want it as done as possible. Let's do another one. Those are fun.
Does log just stand for
Logarithm.
logarithm?
Yeah.
It doesn't have a number associated with it?
No, you have to have a base with it. We'll get into all that.
But why do we...
We need it to undo exponential functions.
Why do we have to, like, write out log?
Really? I could make you write out the word logarithm every time.
Well, that's all I'm saying. Like, really,
I don't want to write out the word logarithm every time. I want to write out log.
No, well, but why can't you just write 832 equals log? Like, what'll 832?
Like, what is log? What's the point of log? Why is it
The
even-
log is telling me it's the inverse of a exponential function. If you just wrote 8 and then a 32, I'm going to think it's 8 to the 32nd power. I have no idea what that means. It does not get more shorthand than this. Good as it's going to get. I'm going to start with me. Log base 5 on 125. Here's what we're going to do. We're going to let it, we want to know what that is equal to. So we're going to say, oh, I don't know right now, so it's going to be equal to y. So change this to exponential. 5 to the y equals. Now the trick is, can we get them to be in the same base?
Yes.
We can't simplify this one anymore. 5 is 5. But what about 125?
5 to the third.
Bases are the same, so that means y equals
3.
3. So log base 5 of 125 equals 3. I'm going to add another one. This is going to be awesome.
Miss White, what if it's or like
Non-do exponentials,
whatever?
I have no idea. I just like to do them.
Okay.
I'll be honest. Oh, this white just stepped it up. Okay, what are we going to let it equal?
Why?
So we're going to say 64 to the
130.
up.
64
Y.
y
Equals
136.
Okay. Now this is a little trickier. Can you write 64 and 32 as something to a power?
Yes.
What? 2, base 2. We did 32 earlier, so this is 1 over 2 to the 5th. We'll have, 32 times 2 is 64, so 64 is 2 to the 6th.
6.
Is that okay? Now, over here, we're going to multiply the exponents, so it's 6, oopsies, JK, 2 to the 6y. Now, I can't deal with this because it's in the denominator, but can I bring it up top?
Yeah.
What happens to the exponents when I bring it up top?
Turns negative.
Makes it negative. This is why knowing your rules of exponents is super, super important. So now the bases are the same, so
6y equals -5.
6y equals -5, so y equals
-5, 6. Ooh.
How are we doing? Okay. Now, I would like you to look at your calculator. Look next to 7. What do you have right next to the 7?
Log.
Log.
Oh.
But, really?
Found it.
Turn a little red there. Good. Okay.
There's a strong.
Right next to the 7, not the 8, the other direction, is the log button. Now here's the trick with this. That's not log base whatever we want. That is only log base 10. I know. So there's no log base 8 button or log base 7 or log base whatever. Only log base 10. There's actually one more, but we'll tell you about that later. Log base 10 we write as just log. This is known as the common log. Base 10, log base 10 is known as the common log. And because it's a common, we get to shorthand that a little bit. We don't have to write the base. So if I just said log of 100 equals what? I didn't give you a base. So you have, when there's nothing written there, it's an assumed 10. Can we solve that one?
Yes, yeah.
What did we do?
10 to the y equals 100.
100 equals 10 to the second.
So y equals?
2.
Do we always have to write them out?
Yes.
Even if it's
Yes. Answer your question. Don't keep arguing with me. Don't even start with me. Okay. So we understand common log base 10. Yes?
But is that the log that we use?
On your calculator.
Is it like a log?
There's log base E, and that's a different one. That's a
So
special one.
wait, if it's other than log base 10, you can't do it on a calculator.
You can't do it on your calculator. Not yet, anyway. There's a way to do it.
What
but I
about
haven't
the
showed you yet.
TA89?
No, you can't. Get over it. So here's a question. So where are we going to use? Where do they use this stuff? Here's one place where they used it. I didn't think of it until right now because I read it. They actually have a logarithmic scale for the Richter scale when they measure earthquakes. It's actually a logarithmic scale that they use. And it's all about magnitudes. So if you look here, the Richter scale, magnitude, energy release. So that's what they use to measure it. They measure the energy, and they figure out what power greater is it, what magnitude is it of that. Is that okay? So there's an example. So we're actually going to do this with problem 3. In December 2004, an earthquake with magnitude of 9.3 on the Richter scale hit northwest coast of Sumatra. Diagram shows. Okay, so then there's a diagram. But they give us this. They give us the formula log, and then they give I sub 1 over I sub 2 equals magnitude m1 minus m2. It compares intensity levels where I is the intensity determined by a seismograph. How many times more intense was December earthquake than March? Okay, in December, it was 9.3, and in March, it was 8.7. And so what we need to do is we need to use this to figure this out. Now, they're not going to ask us for I1, I2, okay? They just want us to figure out how many times greater. Here's what we're going to do. Let's plug in our M1. Let's plug in our M2. So 9.3 minus 8.7. What's 9.3 minus 8.7?
5.6.
We're going to change this down to exponentials. Let's change this to exponential.
I1.
What's my base?
10.
10. So 10 to the 0.6 is the same as the intensities. And I want to know approximately how much more intense, so I'm actually going to figure out what 10 to the 0.6 is in my calculator. And that's about how many times greater or more intense the first earthquake was than the second. Does that make sense?
Yeah.
What is 10 to the 0.6?
3.98.
3.98, so it's about 4 times more intense.
Doesn't the Richter scale go up by,
I'm not 100%. I've never seen
like, isn't it like a 9 earthquake, like,
Oh, it's huge.
a million times stronger than like a 4 or
It's something like that, yeah.
Yeah.
I don't remember, but yeah. The last thing we need to look at today. Actually, you know what? I'm gonna break this up today. I'm gonna stop right there. We'll finish the notes tomorrow. But here's what I would do. You can start this. Right now, of the homework, get 12 through 28 done tonight.
Can we finish our worksheet?
Yeah, you can use the rest of time how you need.
Miss White, are you gonna be here after school?
Yes, but I'm not staying really long because I don't think that, so you need to come right away.
Okay.